All right, welcome to The Explainer. Today we're diving into a book that puts forward a pretty wild idea. What if the story we've been told about our planet is missing its main character? What if there's a huge, powerful force out there that's been shaping our world all along and we've just missed it? And the book kicks off with this really provocative idea. It says, look, Earth's history isn't this story of slow, stable change. No, it's a history of cycles. Intense, periodic upheavals that completely reshape the planet and everything on it. And these cycles are driven by forces that maybe, just maybe, conventional science has overlooked. And that really sets up the central question for us today. What if we're missing the biggest piece of the puzzle? What if the most powerful force shaping our world is hiding in plain sight? So yeah, let's dive in and break down the book's main arguments. Okay, so to even begin to understand the author's claims, we have to get on the same page. We need to learn what the book calls the sun's hidden language, and that means getting a handle on the basics of space weather. First up is the solar wind. And don't let the name fool you. This is not some gentle breeze. We're talking about a constant, high-speed blast of charged particles streaming away from the sun. Sometimes it's moving at over 2 million miles per hour. And the author really stresses this point. This solar wind creates a massive electric field that basically connects everything in our solar system. Then you have coronal mass ejections, or CMEs. The book has a great way of putting it. They're the thunder to a solar flare's lightning. These are just massive, explosive blasts of plasma and magnetic fields. We're talking huge electromagnetic shock waves that can cause some serious space weather here on Earth. And get this for scale. A single one of these can blow up to be wider than Mercury's entire orbit in just one day. Wow. And what about coronal holes? Well, they're not really holes in the way you might think. It's more like an area where the sun's magnetic field lines are open, and they act like giant nozzles, just spraying these super fast streams of solar wind out into space. So yeah, think of it like a high-pressure jet of solar particles. So how can we tell the difference when one of these things hits Earth? Well, this is where it gets really interesting. According to the book, it all comes down to timing. A CME, that hits like a brick wall. Speed, density, temperature, bam, everything changes at once. But a stream from a coronal hole, that's different. The author uses this fantastic analogy. Imagine a snow shovel. The slower particles get pushed ahead of the faster stream, piling up like snow on the blade before the shovel itself actually hits you. So scientifically, you see the density spike first, and then the increase in speed and temperature follows. Pretty cool, right? All right, now that we have that space weather 101 down, we can get to the core of the book's argument, because it takes this knowledge and directly challenges the mainstream climate narrative. And just a reminder, we're here to neutrally explain the arguments from the book, not to take a side. So the author poses this fundamental question. Is CO2 really the whole story? The argument isn't that it's not a factor, but that it's being presented as the only story, and that in doing so, we might be completely overlooking other, way more powerful drivers of our climate. And to build this case, the book lays out a few key counter-arguments. First, it points to events in the deep past, like Dansgaard-Oeschger cycles, arguing that the climate swings back then were way more extreme than what we're seeing today. It also highlights eras when CO2 levels were like over 4,000 parts per million, and these were times when biodiversity exploded. And then it pivots to the modern day and starts to question the very data we're using to measure climate change. A huge part of that critique has to do with data integrity. The book talks about something it calls NOAA ghost stations. The claim is that a significant chunk of the U.S. temperature data might actually come from weather stations that were shut down years ago. So instead of direct measurements, the values are estimated or infilled by models. This naturally raises the question, how much of our temperature record is real data versus a computer's best guess? And it doesn't stop there. The book also highlights criticisms from people like Tony Heller, who argue that the historical temperature data is constantly being adjusted. And, according to them, these adjustments almost always go in one direction. They tend to cool the past and warm the present. The result, they claim, is an artificially steep warming trend that wasn't there in the original raw data. But here's maybe the most counterintuitive argument in the whole book. It says, okay, even if you accept the warming, the planet has this wild, built-in feedback loop where too much heating can actually trigger a sudden, dramatic cooling. The idea is that as ice sheets melt, this massive pulse of fresh water gets dumped into the North Atlantic. This can shut down the big ocean currents, the ones that act like the planet's conveyor belt for heat. And when that shuts down, the Northern Hemisphere can plunge into a rapid cooling period, just like what we think happened during the Younger Dryas event. So, if the book is arguing that CO2 isn't the main driver, then what is? Well, this is where it all comes back to the sun. The author argues the real answer is written in the sun's signature on our atmosphere, and specifically in how that solar energy actually gets delivered to our planet. And this is where the book claims mainstream climate science makes a huge mistake. It says they focus almost exclusively on something called total solar irradiation, or TSI, basically just the total brightness of the sun. But this chart shows the problem perfectly. During a massive solar flare, the total sunlight, the TSI, might actually dip a tiny bit. But look at the X-ray energy. It can skyrocket by over 1,000%. That's a massive injection of energy the TSI completely misses. And if you're not measuring that, the book says you're going to get the sun's influence totally wrong. So, what's all that extra energy actually doing? Well, according to the book, it has a direct impact on our jet streams. When the sun is really active, it helps keep the jet streams tight and pushed up toward the poles, which generally gives us more stable weather. But when the sun gets quiet, the jet streams weaken and start to meander all over the place. And that's when you get those big dips that bring frigid Arctic air way down south, causing those wild, extreme cold snaps. The sun's influence doesn't stop there. The book also draws a line between solar activity and the El Niño-La Niña cycles, ENSO, which is a huge driver of weather all over the world. The argument is that the end of a solar cycle, that really rapid transition from one to the next, it's like a jolt to our climate system. And that jolt can directly influence how strong the next El Niño or La Niña is going to be, which, if true, gives us a potential way to predict major weather patterns based on what the sun is doing. Okay, so where does all this lead? What does it actually mean for the future? Well, the book proposes a completely radical shift in how we think about and forecast our world. Just try to imagine turning on the weather report in, say, 2030. According to the author, your local meteorologist isn't just going to be talking about temperature and rain. They'll be giving you updates on the solar wind, readings on cosmic rays to forecast hail, and warnings about solar flare activity and how it might affect a hurricane's path. The book even imagines forecasts for things like seismic risk based on atmospheric electricity, or even cardiac health warnings for vulnerable people based on the day's space weather. It's a whole new world. And so, when you get to the end of it all, the book really leaves you with one simple but pretty profound question. In our intense focus on the atmosphere right above our heads, have we been looking at the wrong sky this whole time? Have we completely missed the main driver of our entire world, coming from much, much further away?